In this lesson, we'll be creating a closed loop circuit with a 5-second timer delay. Alright, welcome back everyone. Today we'll be creating a closed loop circuit with a 5-second timer. And we're going through various throttle switches, as you can see over here. And we're going to see how these various throttle switches, how each one interacts with our closed circuit. Alright, so let's begin. I'm using RSLogix Pro to create my ladder logic. This right here, we're going to start off with a normally open contact, and with RSLogix Pro, you can just easily just bring your mouse over here to the input and drag it and drop. All right, and then we're gonna, to make sure we have so when we throttle our switch, when we press the button, we want our load, or in this case our light, to come on. We want our output to come on, and then when we press the button again, we want our light to go off. Alright, so this right here is where we can create our OR statement, or OR gate rather. So we're gonna bring in a normally closed contact here, and this normally closed contact will be our output. This is our initial load. So we just drag this here, and let me see, we'll bring another normally open contact here. And your output over there. Now we're going to be using memory bits, and to get to your memory bit, you right click and come down to the data table. All right, and our memory bit saying RSLogix Pro would be up under B, so up under binary. So we'll go with this one. Drag and drop. And then we'll do it again here. Now the reason we've got the same bit here, because this closes this circuit. So when this circuit is true, it will latch here. So when we press our push button, this will close our circuit and create the loop. Okay. I'll go in more detail about this contact in a second. Alright, so that's our first rung. As you can tell, these are our rungs right here. Let's come down to the second rung. Now don't forget, we will be using a timer, and I'll get into that in a minute. But right now, let's set up our ladder logic for just the circuit itself. Now let's say if I made a mistake right here, and this is supposed to be normally closed. All I have to do is go to right click, go to change input output, and now it becomes normally closed. But in this particular case, we want it to be open. Put our memory bit in. Now the purpose of these is if this bit is on, this bit will be off. When this bit is on, this bit will be off. This output will be off. That is the purpose of the throttle switch. So when we click it one time, it comes on. Click it again, it turns off the load. Alright, let's come down here and create a third rung. Now the third rung, this is initially our load right here. Alright, so just click the little arrow up here. Let's hide this. Let's download our program and let's test it out. Voila. So when we push the button, our load becomes true. Push the button again, our load becomes false. True, false. Alright, now let's switch up the throttle switches here. Alright, this is a normally close. Normally close, okay, so that means the push button would be normally pushed in. Pull it out, cuts off. Pull it out again, cuts on. Alright, and these throttle switches right here, this would be like your limit switch. So let's say something on a conveyor or anything, we be running and hits a limit switch. Alright, hits the limit switch. Well, the limit switch is engaged, but as soon as it goes off the limit switch, the light goes off. Hits the limit switch again, comes on. Hits the limit switch again, goes off. And now this is a normally closed limit switch, so that means it's not true. Hits the limit switch, off. Vice versa. And this is just your basic switch, like your light switch. Close the circuit, lights on. Now with this one, it's a little bit different. You have to click it, you have to cut it off twice, on twice. Now that's a little bit different. That's something we would do more of a XOR gate logic for. So that doesn't really hold its value with this circuit that we're using today. This circuit is mostly designed for a push button. Alright, now with that being said, let's add our timer to it. To add a timer, all right, we'll go back to program here. We'll go to timers, and we want a delay timer. So it'll be timer on. We'll set that here. Go to our truth table, timers, and we'll see our first timer here. Drag and drop. All right. And we'll set our preset to, I think it's 20. 20. Now, because we added that timer, we're going to add another contact to our second rung here. We're going to add a normally open contact here. And this contact will actually be representing the timer itself. The timer. Like literally the timer of the timer. So while the timer is timing, it will be energizing this bit. Okay. And then we come down to the last rung, and we'll add the done bit. I will be going in more detail about each of these contacts and their functions, and more in detail of timers in a later lesson. Today we're just creating a simple closed loop circuit. But the function of the done bit is this will not be complete until the timer is done. Unless the timer is done, this load will not come on, and that is the purpose of the done bit. Alright, let's download our program and let's run. Now you can see I can push the button and nothing happens now. Nothing happens. Alright, now if I hold down the button, the timer starts. Within 5 seconds, the light comes on. I release the button, the light goes off. Alright. Now this is on the flip side of a normally closed button. The light will normally stay on all the time unless I pull the button. Once I pull the button, the light goes off. As soon as I release it, after a 5-second delay, the light comes back on. Now let's go back to our limit switches. Alright. Something hits the limit, and it's after it's hit the limit for more than 5 seconds, a light comes on. This can be like an amber light, a red light that lets you know that, okay, the limit has been reached. And once you remove the item from the limit switch, the light goes off. And on the normally closed limit switch, let's say something is supposed to be on this limit. Once it removes off the limit, it goes off. But since the limit's back again, it's be like a caution light. And back to our normal flip switch. This is good for that delay. If you need to have a delay for any purpose, for any reason. Let's say you're doing an irrigation system and you wanted a 5-second delay after you hit the switch. Voila. And this is a closed loop circuit with various throttle switches.